Hello friends, in towards green energy, in earlier video which is energy and use of energy, generation of electrical energy and the thermal energy based electric power stations, okay, and the problems are occurs because of this thermal energy power station. Okay, today let's see power plant based on nuclear energy. In this, steam is used to rotate the turbine of a generator. How it is used? Let's see. In nuclear power plant, the energy is produced. It produced by fission of nuclei of atoms. Atoms is fission, and from them the energy is released. This energy is used to convert steam to form of a steam from water. For this purpose, uranium or plutonium substances are used to generate steam from water under high pressures and high temperature. The energy is used to form the steam. That means here first nuclear reactor for nuclear energy, for nuclear fission reactions take place. Then this energy produced in this process is used to steam generation. Then by using the steam turbine, and then steam turbine is rotate the generator, and generator is rotate into the electrical energy. As a result, from this nuclear energy, the electrical energy is produced. In this system, the steam is condensed and again sent back to the steam generation into water, condensed into water and sent back to the steam generation. This nuclear reactor for nuclear fissions, uranium or plutonium substances are used. Thus, nuclear energy is converted. Thus, here nuclear energy is converted into electrical energy. Means here first the nuclear energy is used. The nuclear energy is heated the water. That is the thermal energy. Then thermal energy is applied on the steam is applied on the turbine, so turbine rotate, so their kinetic energy is formed. Then kinetic energy rotate the generator. There is in generator so kinetic energies take place, and then in generator electrical energy is produced. There are the various type of the energy is used in the production of a electricity in a thermal power station. What is my fission reaction? First see what is the fission reaction. Here uranium in fission reaction 235 or sometimes 236. Uranium 235 or 236 radioactive substances isotopes are used uh, in this reaction. Unstable atoms uranium 35 235 uranium 236 unstable atoms of uranium 236 is converted into barium and the krypton. How it is converted? So for that, the uranium on a uranium atom, neutron is bombarded. What is bombarded? Neutron. Okay. So this 235 uranium is converted into 236 uranium, and then it split into barium and krypton, and also in this reaction 3 neutrons are released. This each neutron then bombarded on each atom of uranium. Then uranium 235 is converted into uranium 236 isotopes. Then each uranium then again reduce or forms barium, krypton and 3 neutron. Okay. In this reaction, the uranium atom is fission to form barium, krypton and 3 neutron. That time, here in this reaction, some amount of energy is released. Here also energy is released. Here also every atom, when it reduces into krypton and barium, that time some amount of energy is released. Finally, it continues to take place, and then togetherly it forms in this reaction a lot of energy. Lot of energy is produced. This energy is used to generate the electrical energy. But there are so many problems. Generally, it is very easy or it is available. But there is a problem that the fission nuclear fuel are also the fuel we are using. It is radioactive substance. It is radioactive and emit harmful radiation, and it releases harmful radiation, so it is also dangerous to use. So what are the problems? The nuclear waste. So nuclear waste will have a challenge to how to handle it. So nuclear waste become dangerous and it has a challenge to how to handle it. Then second one, that if there is a accident, an accident can be very fatal, because by these accidents the radioactive rays or harmful radiation are released in nature, and that will be affects every organisms. Okay, so these are also dangerous for the every living organisms. Then second one is next one is power generation plant based on natural gas. Here the turbine is run by using the very high temperature and pressure generated by combustion of natural gas. That means first by compressor for pressurized air. Their compressor for pressurized air. By using this means here at a very high temperature and pressure the air is compressed, and by using then the in a combustion chamber, by using the natural gas, heat is generated. Then so here the natural in this natural gas in the chamber, natural gas is produce use this natural gas, convert the water into steam, and then turbine is rotate, and then turbine rotate the generator, and then generator forms the electrical energy. There are three main sections. First one is a pressurized air is introduced. The combustion chamber, so by compressor. Okay, so that is the important chamber. Then in this the combustion chamber is also important. There the natural gas is burns in the presence of air, and then in this combustion chamber at a very high temperature and pressure, the chamber, the turbines is runs. So these are the three main sections in this type. So here the chemical energy. First the chemical energy in natural gas. This chemical energy is converted into kinetic energy due to combustion of natural gas in the chamber. The kinetic energy is produced, so the gas is get converted into kinetic energy, and then this is used into the turbine, so their kinetic energy is produced, and then in a generator finally the electrical energy is produced. So here the chemical energy converted to kinetic energy, kinetic to kinetic, and then kinetic energy to electrical energy. Its efficiency is higher than the power plant based on the coal. It has a higher efficiency. It produces more energy than the coal power station, thermal power station. So natural gas does not. So this gas does not contain the sulfur. As a result, in this natural gas in this power plant, the pollution is produced. That pollution is also less. So though this schematic power plant based on the natural gas. See here in your table it is given, diagram is given. See the fuel, that is the natural gas, is enters into the combustion chambers, so that it is heated under compressor the pressure. Then this gas is here the kinetic energy produced. This kinetic energy used to rotate the turbines. That time the hot gases is released into the air. Only gas is released, so there is no harmful effects, and that is why the turbine generator rotates and the generator produces the electrical energy. See that is why it is important. In India, the Samalkota in Andhra Pradesh, the natural gas power plant is present, whose capacity is 2620 megawatts. Then at Anjanvel in Maharashtra, the capacity of that plant is 2220 megawatt. At Bhavana in Delhi, 1500 megawatt capacity there, and Kondapalli at Andhra Pradesh, its capacity is 1466. So by using the electricity generated throughout the India, it is the important that it do not causes any pollutions. Okay, next lecture we will see electric energy generation and environment. Thank you so much.